Okay, so remember what we said in the first lesson of organic chemistry. So organic chemistry is the study of the molecular compounds that have carbon on it, and carbon very is an element that has a very high bonding capacity as 4, because in the outer shell there are 4 uh, electrons that are willing to be bonded with other elements. The most common one that we see that carbon is bonded with is hydrogen, and then we have those um, beside the fact that it's when we see carbon and hydrogen only, then we straight right away think that this is an organic or is a hydrocarbon compound. Um, there are some exceptions. So uh, when we see carbon into a formula, then the very first thing that we have to think of is this is an organic, except when we have uh, carbon oxides or carbon monoxide or carbon dioxide. So in other words is oxides. When we see oxides like carbon oxide or carbon dioxide, then we think that we classify them as a not uh, organic compound. The other exception is when we are dealing with carbonates. So when we see carbonates is one of the polyatomic CO3 minus. So when actually it's 2 minus. When we see this, then we say that, okay, uh, we see it in a form of a salt, let's say sodium carbonate. This is not considered to be an organic compound. The third exception is when we have cyanide. Cyanide again is a polyatomic. Anything that has CN, it's not considered to be uh, an organic compound. And the fourth exception is when we have carbides. Carbides is when carbon is connected, is bonded with carbides. It's bonded with another element. So let's say silicon carbide. Okay. So all those cases are not. Now we said that carbon has it's a very high bonding capacity because it has 4, and then hydrogen has 1. Why does it have 1? So carbon has 4 bonding capacity, meaning that it's able to connect with 4. In a Lewis dot diagram, this carbon will be something like this. And then hydrogen, that is the first element. Remember that it has 1 bonding capacity, because we see hydrogen as the one that is on the first, has only 1 outer shell, and on that outer shell has only 1 electron. So hydrogen is something like this. But even the elements that are in the group 16 of your 17 of your periodic table, so elements like fluorine, chlorine, bromine, iodine, and so on, has a 1 bonding capacity. Okay, so when the carbon is able to connect with either hydrogen or an halide, that is the group 17, then what it is able to form, it's able to form single bond. So in the case when we have CH4, then it is something like this as a structure. And we are not going into a structure or Vesper diagram, not at all. Or it is able to bonded together into double bonds. So two carbons are connected with a double bond, meaning that what do you have here? You have left two more bonds for each of the carbons, or when they may be bonded together into a triple bond. So when we have the two carbons are connected between each other with a triple bond, and then what is left here is one hydrogen, which we are assigned like have it like this on the top, or very often we see it like this. But as I said, we are not going into Vesper diagram, so any way that you are writing it in terms of the structural diagram, then you're good. And then we talked about the way of communicating in organic chemistry. So it is the first one is the molecular. When we have molecular, when we write the molecular form uh, of the compound. So let's say butane. The second one is when we have an expanded molecular formula. And when we have the expanded molecular formula, it is just showing what each of the carbons is bonded with and how many. So first one is bonded with 3, and then the second one is bonded with 2 hydrogen, because 2 bonds are going to be connected with a first carbon and with a third carbon for the second one. And then the third carbon, same deal. And then the last carbon has CH3. The third way of communicating in organic chemistry is the structural formula. When we are writing down as to how is the carbon connected with. So in this case, when we have 4 carbon, butane, 3, 4, then we have first one is with 3, because what we are doing is we're completing the molecules or atoms of carbon with for the whole all 4 bonding capacity that we have into the into as a possibility for carbon that are 4. So we have to have for each carbon 4 lines. The fourth way is when we are using that is known as the condensed structural formula. Condensed structural formula, when we are just showing the connection between the carbons, and then the other, in this case hydrogen, is just showing as a number. So when we have something like this, carbon, 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 and then this first carbon has 3, the second one has 2, the third one has 2, and the last one has 3 hydrogen. And the fifth way, which is used very often by students and teachers, is that is known as the line structure. When we are structure, when we are just drawing the lines in up and down shape like this. So those vertices, those that I'm emphasizing here, are representing carbons. So here what do we have is a carbon, 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 carbon. But then we do not show anything else into this. Okay, next thing that we saw in the previous lesson is how can we group hydrocarbons. Okay, So all of those that are known with a bigger name as hydrocarbons or organic compounds are classified. Why are they classified? To be studied, for easy study. Okay, so the very first group is that is known as aliphatics. So, and within this group, what do we have is we have three subgroups. So the first one is alkane. We saw this and we talked about this, and I will add here whatever we did in regards to this. When we are talking about alkanes, the general formula of an alkane is Cn, so carbon, number of carbons represented as N, and the number of hydrogens is 2N plus 2. What do we have on this is that we have a single bond between the carbons. Okay, so what do we see is something like this, and then it depended on how many chains or how many carbons do we have in our chain. Another thing that is important to emphasize when we are talking about alkanes is that they are saturated. So when we see a hydrocarbon compound that is a single bonded, then it is an alkane and it is saturated. Okay, now the second group of the aliphatics is that it is known as the alkene. Okay, the general formula for alkene, this is something that we haven't seen, so we didn't talk too much about this, is C as representing the carbon, N representing the number of carbons into the hydrocarbon compound, and then the number of hydrogens is H2N. Now, what do we see here is that we see a double bond. We talked about the fact that carbon can be connected between each other in a double bond. And this will result into having a hydrocarbon that is unsaturated. The reason that it is not saturated or it is unsaturated is because in water, when we have this in water, what we see is that the two carbons that are connected with a double bond, one of the bonds can be broken, creating the same length of chains of carbons. So it doesn't, quote unquote, change the structure of the carbon chain, but makes it a single bond, which is saturated. So every time that we see that we have more than, even one carbon between each other that is not, it is a double bond or a triple bond, then you have to think of that double bond or triple bond as, if I break this bond, let's say double bond, if I break this bond, then still the carbon chain will not changing, but what will happen, those two bonds will go, this bond that you are breaking will go in each of the carbons that were in double bonds. So we'll have something like this. This bond will be broken here, and then what you will have is the bond will go here, and this will move from unsaturated into saturated. Okay, so even when we have three, then you will have this, then you break one, and then you have still unsaturated, and then you break up the second one, and then you have saturated. Okay, so this is unsaturated. This is unsaturated as well, because you have the opportunity again to break the bond between the carbons and then not change the chain of the carbons. And this one here will end up to be saturated. The third group of aliphatics is the one that is known as the alkyne. So when we are talking about alkyne, the general formula of it is CnH2n minus 2. What do you see is a triple bond, triple bond between carbons. So you will see something like this. Of course, as we said, even in the explanation before, it is unsaturated. Will become saturated when you have only the single bonds. Okay. The second group of the hydrocarbons is that is known as the aromatics. So aromatics, what do you see is that is known as the benzene. Okay, something like this, C6H6, and the name for it is benzene. The structure of a benzene is an hexagon that has on every other pair of carbons you have a double bond. Very often this structure of the benzene, so on each of them you have a carbon, 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 and one hydrogen on each of them. Okay, because when you see it 1, 2, 3, 4, carbon is satisfied with four bonding capacity. It has 4 bonds. Very often, benzene is not just represented as this double bonds, because what is happening with those pairs of electrons, they are constantly moving. So if for simplicity we are saying this is 1, 2, 3, 4, 5, and 6. So if you see that you have a carbon between 1 and 6, or an electron pair between 1 and 6, then they move, they go to 1 and 2. And so that they push the 2 and 3 to 3 and 4, they push, those are pushing 4 and 5 to 5 and 6. So very often the structural diagram or formula of benzene is represented even as a circle inside, because those electrons are moving constantly, and when you see it, actually it is like a motion that is going on and on and on and on, creating the idea of a cycle. If benzene though is as a group, then benzene is known as phthalene. This image right here, does anyone recognize this guy? Phthalene. Okay. You see, we will see this naming of all of them today and finish up with that, even though that we did just alkane, and we'll finish with everyone. Okay, the next one is that is known as the hydrocarbon derivatives. So what do you have? The word derivatives is saying to you that is derived from the main thing. Derivative is as a result of something that you're doing to the main thing. So when you have a hydrocarbon, either an aliphatic or an aromatic, and then you are taking one of the hydrogens and you are substituting it with something else, then what you are doing is you are creating that is known as the derivatives. They can be, the first one is organic halides. What is happening in those is that one of the hydrogen is replaced with the element of the group 17. So when we have, let's say, CH4, when we write it as a structure, is a hydrogen and then a carbon like this. However, one of those is replaced now with an element of the of group 17. So what do we have as a structure on this case is something like this: hydrogen, 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 and then here, let's say that we have chlorine or bromine or fluorine or something like this. Okay. The second group on the hydrocarbon derivatives is that is known as the alcohol. So alcohol, it's again, one of the hydrogen is replaced with hydroxyl, which is the group OH. So when you see, let's stick with methane here. As a structural formula, we'll have hydrogen, 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 and hydrogen. And now one of those hydrogens is replaced with hydroxyl. So what do we have now is an alcohol, CH, H, H, and then here we have hydroxyl. Okay. The third group, beside the alkydes and alcohol, is carboxyl acid. So carboxyl acid, again, the same idea. It's derived from the main. So you are taking one of the hydrogens and you are replacing it with a group, a functional. Those are known as the functional group. Carboxyl group is in this form. We have a double bond with a hydrogen and a single bond with hydroxyl. So when you see this, that one of the carbons is connected with a double bond hydrogen and a single bond hydroxyl, then we have a carboxyl acid. And then the last one is esters, which we actually will do it as the first one in terms of the way that we will name it. So it is something like this: a double bond, and then we have a single bond of the oxygen. Okay, so this is in terms of the grouping of those. But every time that you are looking at the derivatives, think of the root of the word derivatives, which is telling you that is derived from the main thing. And the main thing is every aliphatic or aromatic that we have seen, because there are more than one aromatic, but we will focus only on benzene. And then one of the hydrogens in the carbon bond, it is replaced with a group, with a functional group. Sometimes this group is just an element, like in the case of the element of group 17, like chlorine, bromine, fluoride, and so on. And sometimes is of another functional group, like hydroxyl, carboxyl acid, or ester. So this is how hydrocarbon derivatives are formed as a principle. So you see one hydrogen is removed, is taken away through a reaction that we will see, and then it is replaced with the group or the element. Now let's talk a bit about naming. We started to name alkane compounds, and now we will we'll finish with everything that is in aliphatic first. We'll have a short break and then we'll continue with the rest of them. Okay, so when we are naming, what do we have to keep in mind is the number of carbons. And on this case, a table that you need to memorize, it is very helpful. Okay, so this table continues up to 10. So you will continue with 5, that is pent, and then pentane, pentene, pentene, hex, hept, oct, non, and dec. You need to memorize this, and you need to know how to name something that is aliphatic. When we have an aliphatic that is not branched, then we just say the name. We count the carbons and then we write the name. So let's suppose that we have pentane, then will be the structural formula will be something like this. And then you have carbon or hydrogen all over. When we have a branch, then what we will do is we'll find the longest carbon chain. You have to count and to see all the opportunities that are to have the longest one. So you will count 1, 2, 3, 4, 7, 1, 2, 3, 4, 6, 1, 2, 3, 4, 8. That will be the longest chain. Well, circle the groups. I will suggest you, recommend you to write the group name as well there, and then label the carbon so that the group is first. But when you are naming the hydrocarbon, we will keep in mind the alphabetical order. So let's say E comes before M. So if you have two groups, one that is ethane and the other one that is methyl, so methyl and ethyl, then you have, even though that ethyl can be down into the carbon chain, it has to come first when we name it. So let's suppose that we have something like this. So we have a carbon chain with 3 carbons, and then right here in the middle we have a CH3. Okay, so now this has three the longest chain is 3, because if you start counting it, will be 1, 2, 3, or 1, 2, 3, or 1, 2, 3. So the longest chain is 3, and it doesn't really matter how do you name it, how do you label it. Do you label it as 1, 2, 3, or the other way? Why? Because the branch that is this one here, that since it has only 1 carbon is meth, that will be in the middle. Any way you are going, left to right or right to left. So when we are naming this, since we have 1 branch, then we will say 2, that is the position of the branch, the name of the branch, so methyl, and then the name of the chain. Since we have 3, we'll use prop, and it is a single bonded propane. But when we have more than 1 branch, like in this case here, when we have carbon, 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 and then another one, another one, another one, and then we go And then here we have H2 and CH3 and another CH2 and CH3 here. And then we have another one here at CH3. So now, as you see it here, we have three branches. We have one branch here on this position, one branch here on this position, and one branch here on this position. Those two are both with the same one as ethyl. So this comes first into the naming when we are naming this hydrocarbon, independently if it is the first branch that we see when we label the carbon or not. And this is methyl. Now let's start labeling and finding the longest chain. So 1, 2, 3, 4, 5, 6, not the longest, or 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So therefore, the longest chain is this one here. Even if you are using like a highlighter when you are defining the longest chain, it's good to do so. So now let's start numbering the carbon, but we'll start so that the branch, when we are walking into, we see the branch. So if we are labeling on this way, 1, 2, 3, 4, the first branch will be at 4. But when we are labeling on this way, 1, 2, 3, the first branch is on the 3. So therefore, we will use the this way of labeling it: 5, 6, and 7. Okay, so now in alphabetically, E is before M. E for ethyl is before M for methyl. So what do we have on the, we'll start with the place. 4, 4, even though that they are same numbers, we have to state them. And since we have on this carbon, we have 2 ethyl, we'll go di ethyl. And then on the third place, we have a methyl. And now we have 7. What does it mean, 7? What is the root of the prefix for 7? Heptane. Okay? Makes sense? Let's see now, how are we deciding to name when we have a double bond or a triple bond? So, or when we have an alkane or alkene, okay? Keep in mind they are unsaturated because the bonds that are double or triple, you still can break that bond without changing the structure of the chain, okay? We will use pretty much the same logic and the same structure as we used for alkane, because for the aliphatics. But you have to keep in mind that the longest chain, the longest carbon chain, must include the double or the triple chain bonds, sorry. So keep in mind when we are counting the carbons, as we counted the carbons on the longest chain for alkane, that we were going any way possible. On the case of the alkane or alkene, we have to consider that the longest chain has to include the double or the triple bond. And when we are naming or when we are labeling the carbons, was 1, 2, 3, numbering the carbons, we have to keep in mind that the double or the triple bond has the lowest number in the numbering the carbons. Okay, so we said that at the alkane we will see which one has the closest branch. What we will do here, we will see which one has. How can we start so that the double or the triple bond has the lowest number of carbon? And then for the parent chain, when it is unbranched, we'll just go with ending for alkene will be E-N-E. So alkene, E-N-E. And for alkyne will be Y-N-E. The ending will be Y-N-E. So if we have an ethane, C, hydrogen, 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 and hydrogen, then the root of two carbons will be F, since it is double bond, ethene. Okay, but when we have something, and in this case we do not say at what position is it, because it doesn't really matter. We have only two carbons that are bonded between each other, so they always will be the same. If you say 1, 2, 2, 1, it's the same thing. Well, when we have something like this, CH3 and then one carbon, double, or let's say a triple bond here, carbon, 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 1, 2, 3, 4, 5. Let's stop here. Okay, so here we will have H2, here an H2, and here an H3. Okay, so if we are starting to, this has a triple bond here, okay? If we are starting to, and there is no branch in here, if we are starting to number the carbons here, then we have two ways. We have to number it as 1, 2, 3, 4, 5, and 6, or we can go 1, 2, 3, 4, 5, and 6. When we go in this way, what do we see here is the triple bond is between 2 and 3. So at 2, we see the triple bond. But when we are numbering this way, then what do we see here? At 4 is the triple bond. So therefore, the correct numbering carbons will be the top one, because it is the triple bond in this case is the closest that we see. So since we have 6 carbon chain, then we'll name it as hex for 6. At the second place, we have a triple bond, so 2. And then, since it is a triple bond, it's with ending Y and E. Make sense? If this was a double bond, then the ending will be E and E. So hex 2 wine. Okay? So let's suppose that we have this. So we have 4 carbon chains, and now the longest carbon chain, the one that we will consider it as the the longest chain must include the double chain. So let's count now. So let's suppose that we start as 1, 2, 3, then 1, 2, 3, 4, then 1, 2, 3, 4, 5, and then we have a 1, 2, 3, 4. Always on all the counts. If you want, I can kind of circle them so that you can see as to what I did. So the first one, I did this one. And then as the second one, as the second count, I did this one here. And then as the third one, I did this one here. Okay. And then as the last one, I did this one. So when I counted them, I figured out that we had a chain that includes the double bond on this case, and the longest one has 5 carbons. So 1, 2, 3, 4, 5. This is the longest one. So let's erase those other ones so that we are not confused by all those lines that we see here. So now let's see the numbering the carbon. We said that the rule will be so that we number the carbons so that the double or triple is the first one. So then 1, 2, 3, 4, and 5 will be the one that we should number it. And then let's identify the branches. So we have a methyl. We have another methyl here. And we have another methyl here. Even though that I didn't write the H3, it is there. It is present. Now, how are we naming this? How many carbons do we have? We have 5 carbons. What is the prefix for 5? Pent. So we'll start pent first, okay? To indicate that we have 5 carbons in the longest chain that includes the double bond on this case. At which position is the double bond? On 1. Good. And then we start with the branches, okay? Because, sorry. We always will start with the branches. We always will start with the branches. Where are branches positions? In which place are the branches positions? 2, and then 3, and then 3, okay? We have 3 of the same, meaning that we have 3 methyl. And now we will work with the longest carbon chain. We have 5, so pent. On the first one, we have the double. And then, since it is double, we'll add ENE. So 2, 3, 2, 3, 3, 3 methyl, pent, 1 NF. Yeah. Let's take a look now at something that it is known as the cyclic, okay? So what do we see here is that what we have seen up to now, we have seen that the carbon was in one chain, and there were cases that were branches on it, and there were cases that there were no branches on it. However, carbon can be bonded even into circle. So when we are, what do we see into a circle is something like this. So we have, let's suppose that we have 3 carbons, and then they are connected into a circle between each other. So we have 1 carbon here, 1 carbon here, 1 carbon here, and then we have 2 hydrogens on each of them. Okay, hydrogen, 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 hydrogen. Okay, so the general formula for a cyclic is CnH2n. Okay, because each carbon is connected with 2, but then they are not double bonded, but they are, in each carbon will have 2, and then it is in a circle. It is closed in a circle. The way that we name something that is in a circle is by adding the word cyclo. So in this case will be just cyclo, meaning that it is in a circle. And then since we have three carbons, then will be what is the root for 3? Propane, because we have a double bond here. When we have 4, then we have 4 carbons into a cycle, then will be cyclo, okay, cyclo, bute for 4, and single bond butane. Well, when we have a double bond or a triple bond in a cycle, let's suppose that we have an hexagon like this, and then we have a double bond here. We always will start, so the double bond is number 1. So 1, 2, 3. And let's suppose that here we have ethane, ethyl, 3. Ethyl, and this is 4, 5, 6. Then we have an ethyl here. In which place is the ethyl? It's on 3. Then dash, the name of the branch. And then what do we have here? A cyclic. So cyclo and hexane. We don't have to mention at what place is the double bond or the triple bond in the cycle, because it is supposed to always start with at the first place. Okay, so always the double bond will be at the first place. Make sense? So if we have, let's suppose you have a pentagon, and then you have a double bond here, and here you have a methane, and here you have a methane, and here you have an ethane. Then numbering of the carbon, since we are dealing with cycle, always will start where the double bond is. So 1, 2, 3, 4, 5, and then this is ethyl, this is methyl, so we have dimethyl, 2-methyl, and then E comes before M, so at 4 we have an ethyl, and then at 3 and 5 we have dimethyl, and it's 5, so it's pent. We have a double bond here, E-N-E, pentene. It doesn't really matter if it is clockwise or counterclockwise, whatever you want, it's fine. Whatever you want, it's fine. You should be able to move even from having a name into drawing a structure. So if we have something like methyl cyclohexane, so you have the thing with having the name and drawing the structure, you always will start from the last thing, because the last thing is telling you what is the structure that you have. You have a cyclohexane. So 1, 2, 3, 4, 5, 6 in a cycle. Hexane, single bonded, all of them. And then notice here that in the cycle, we omit that numbering the branch, because when we have only one branch, because it is like that is where number 1 will be, so CH3. If we have more than one, then we have to identify it, or if we have something that is a double bond or a triple bond, then we have to identify it. So in the case when, let's suppose that we have 3 ethyl, 2 methyl, and cyclohexene. Let's make this 4, not 3, not 2. Let's make this 4. Then we have a cyclohexene, meaning that in one of them we have a double bond, but we have a structure that is with 6, like 6 carbons in a cycle. And now where do you start it? Doesn't really matter. Do you go clockwise or counterclockwise? Doesn't really matter. So this is number 1, 2, 3. On the 3 you have an ethyl, so H2, CH3. And on 4 you have a methyl, so CH3, and then you have carbon, carbon, carbon. This will be the structure of it. Okay. When we have something like propyl, when we have propyl, cyclohexane, let's say N, propyl, hexane. Okay, so you have an hexane, this double single bond, and then somewhere here you have a propyl. Propyl has 3, so CH2, CH2, CH3. Okay. Aromatics.